let's move on to the arc length. Okay, so we know what an arc is, but how do we find the length of the arc? So let's just look at this diagram first. So in the diagram, the arc length AB is L. So yeah. And then the angle measured in radians. This is extremely important. If this is in degrees, your calculation and your answer will be completely wrong. So this has to be in radians. So we need to know the angle and the radius in order to find the arc length. So we can use the ratio to obtain, so it's arc length by circumference equals to pi, the theta by 2 pi. This makes sense, right? Because the ratio will remain the same from like the main angle to the smaller angle. The ratio will be the same to the arc length as to the circumference. So and now we can substitute the values in. So arc length will be L, the circumference will be 2 pi r, and this would be theta by 2 pi. We can cancel these two out, so will be theta r. And we can do the same in terms of degrees. So if we use the same formula, then we get the formula as theta by 360 into 2 pi r. So yeah, so for theta in radians, the arc length would be theta r, and then if it's in degrees, then the arc length will be theta by 360 to 2 pi r. So now let's move on to the area of the sector. So in the diagram, the area of the minor sector XOY is shaded. So we can see that, and we know that the angle is measured in radians. So when we use the same ratio, a similar ratio of the area of the sector divided by the area of this circle will be theta by 2 pi. So if we substitute the values in, we get this, which is half theta r squared. So this is in terms of radians, and in degrees, it would be theta by 360 into pi r squared. Okay, so we usually use radians in most of the questions, so make sure that you remember the following formulas. This is extremely important. Yeah. Okay, now let's solve a few questions. Let's solve the first question. So let's read it. So use radians to find the arc length and the area of a sector of a circle of radius 9 cm and angle 7 pi by 4. So we know that L equals to theta r. So we'll substitute the values, which is 63 by 4 pi, which is 49.48. We'll round it to 49.5 cm. Okay, now let's find the area. Area would be half pi r squared. Theta, sorry, my bad. Half theta r squared. So this will be half into 7 pi by 4 into 9 squared, which is 5, 6, 7 by 8 pi cm squared, which is 220 22.66, which will round off to 223 cm squared. So let's check our answer. So it's 49.5 and 223 cm squared. So we got our answer. Now let's do the next one. So it has radius of 4.93 and then angle of 4.67 radians. So L is theta r. So 4.93 into 4.67, which is 23.0231. We'll just write 23.0 cm. Now let's find the area. So we use the same formula. A equals to half theta r squared. So half into 4.67 into 4.93 whole squared. Now let's plug this into the calculator. We get 56.75199415 cm squared. And we can round this off to 56.8 cm squared. It's our final answer. So let's verify this. Yes, that is our answer. So now let's move on to the next question. So a sector has an angle of 1.19 radians and an area of 20.8 cm squared. So we have to find the radius. Okay, so let's write down all the information we have. Okay, so let's write down all the information we have. So angle, so theta equals to 1.19, and area, which is A, is 20.8 cm squared. So we know that area equals to 1 divided by 2 theta r squared. So r squared is 2a by theta, and r would be the square root of 2a by theta. We're not getting plus or minus because length cannot be a negative value. So it's going to have to be the positive value. Now let's substitute the values in. We get 5.9125276648, which is 5.9 cm. Okay, 5.91. Okay, so that's our answer. And now we have to find the perimeter of the sector, I think. Probably. Yeah, so to find the perimeter, we have to know okay, let's draw the sector. Ignore the bad drawing, but yeah. So this is r, theta r. So that would be the perimeter. So r plus theta r. We'll take r common, so. And now let's use the exact value in the calculator. Let's find this. It's 18.860963. We can write 18.9 cm. 18.9 cm. Let's solve the final question. So we have to find theta and a, which is area. Okay, so we know the arc length, we know the radius. So we put in the values here. So 6 equals to theta into 8. So theta would be 6 by 8, which is 3 by 4 radians. Now let's use the area formula, which is half theta r squared. We know that theta is 3 by 4 and r is 8, so 8 squared. So this gets cancelled, so this is just 3 into 8, which is 24 cm squared. So now let's see the answer. Yes, so 3 by 4 and 24. Okay, now let's solve this one. L equals to r theta, same formula, and L is 8.4 and theta we don't know, r is 5. Theta is 42 by 25, which is 1.68 radian. Now let's find the area. Half theta r squared, so half into 1.68 into 5 squared. That's 21 cm squared. So we got the answer.